All right, welcome again to Good Choices. So, didn't make a video for a bit over a week. It's not because I'm making bad choices. It's because I actually made a good choice to go and get a lot of physical exercise by doing a special event. So I was doing that for the last week. That's a good choice. Um, for another week, I will be doing the same. So I could probably do a video tomorrow, but then on Thursday I'll be leaving, and I won't be able to do another video for a full week again, if not a full 2 weeks. So I'm still making great choices in my life. I'm just choosing to prioritize physical fitness a bit for this month over this exam here, which, as I mentioned a million times, I don't know if this is a good exam to go for. I have a feeling the getting my CCNP again might be better for me. Basic cloud cert like AWS, Azure might be better for me. I'm just focusing on this one because it kind of aligns with my philosophies of I really like the open source community. That's just kind of aligns with really well with kind of what I believe. So the fact that these are free and open learning materials, and it's learning about Linux, which is something basically all other technology you'd be learning about. Juniper's run on a Linux distribution, FreeBSD, cloud, those are all working with Bash pretty much, which is basically the Linux front end is Bash, unless you're using a GUI. So it's like, I think this makes a lot of sense. All right, so moving on, with no time to waste, we're still on 103.3 as we were in the last video, but now we're moving on to the second lesson in 103.3. So the topic is GNU, which stands for GNU, not Unix, and then Unix commands, which are the same as Linux commands. Linux is based on Unix. And then the objective of this lesson 2 in 103.3, is to perform basic file management. All right, so introduction, how to find files. As you use your machine, files progressively grow in number and size. Sometimes it becomes difficult to locate a particular file. So fortunately, Linux provides find to quickly search and locate files. Find uses the following syntax. So find, then the starting path, then any options. These are specified usually with dash and a letter, sometimes dash and a more of a word, and then the expression, what you're trying to find. Starting path defines the directory where the search begins. Options controls the behavior and adds specific criteria to optimize the search process. Expression defines the search query. So here's an example. Find, the starting path this is a shorthand for the current directory. So it's anything relative to the current directory, and then dash name is our option that we're going to use, and here's the expression that we'll be searching for. And look at this, they found one called my file. Let's see if my file is found in my version. So all I have to do is type a lab, because I painstakingly in a half an hour figured out how to do that. That's in one of the videos, I forget which one, but you can use the AI or something to try to figure out which one that is. So let's see if that find is in mine. Oh, and it looks like I don't have it. Let's see, look for one that I do have. So last name, there we go, got it right there. And then we'll just search for last. Oh, and now you can see within this GNS3 folder there is a file named last, but it doesn't match on this last name because we're giving it quotes, so matching on the literal full name of the file, which does happen to be last within this GNS3 directory, but in the case of this file, it is not the full name of the file. The full name of the file is last name, which was found here when we specified that. Alright, so the starting path in this case is the current directory. The option -name specifies that the search is based on the name of the file. myfile.txt is the name of the file to search when using file globbing, and we remember what globbing was, but let's get a so globbing is a computer programming term that refers to a mechanism used by command line interpreters in some programming languages to match file names or path names based on wildcard patterns. The wildcard patterns are known as globs, and they allow you to specify a set of files or directories that match a certain pattern. Alright, so terminology comes from the C programming languages, remember, and globbing is basically kind of like regexes, regular expressions, but they're special. They're different from like regular expressions, but they do similar things, and they're used for files, not for text. They're used for files. Okay, so when using file globbing, be sure to include the expression in quotation marks. So here we go. Find. Okay, so in order to find the actual, if we want to match on this without specifying it, we can use file globbing. So here's a glob expression, and now we do have that last name match as well as anything with last in it. This command finds all files ending with .png starting from this directory and beneath. If you do not understand the usage of the asterisk, it is covered in the previous lesson, and I definitely understand it. I feel like the difficulty of this is kind of all over the map. Sometimes it's like UEFI boot up sequence with the system partition, the EFI, I don't even remember what the acronym is, but like that's kind of complicated, and just a wildcard to mean any character is not complicated. Alright, so the next section, using criteria to speed search. Use find to locate files based on type, size, or time. By specifying one or more options, the desired results are obtained in less time. Switches to finding files based on type include -type F, which is a file search, -type D, which is a directory search, -type L, symbolic link search. So these are different options that you can feed it. So they used -name here, which is not listed here. But this is criteria to speed search. So we can use find to locate files based on type, size, or name by specifying one or more options. So here we did it based on name, or sorry, based on type, size, or time. We didn't use any of those. We used name here. So by specifying one or more options, the desired results are obtained in less time. Switches to finding files based on type. So these are different ways you can find the file and make sure that you're not finding directories instead. So you can specify it with -type F, and then you won't get any directories. Or if you're looking for directories, you can specify -type D. You won't get any files, only directories. And finally, you can do -type L, which searches for symbolic links. So find .-type D -name example. This command finds all directories in the current directory and below that have the name example. Other criteria which could be used with find include dash name, so performs a search based on the given name, dash I name, searches based on the name, however the case is not important. For example, the test case MYFILE is similar to all uppercase MYFILE. Dash not returns those results that do not match the test case. Dash max depth n searches the current directory as well as subdirectories n levels deep. Alright, so locating files by modification time. Find also allows to filter a directory based on when the file was modified. Alright, so sudo find, now this is from the root directory, dash name, so we're using a glob here, so we've got a wildcard.conf, so we're looking for all our configuration files, and then dash mtime, when was this modified? So we can see we've got a logrotate.conf file that was modified in a way that matches this 7 integer here. So this command would search for all files in the entire file system. The starting path is the root directory, for example, / that end with the characters .conf and have been modified in the last 7 days. This command would require elevated privileges to access directories starting at the base of the system's file structure, hence the use of sudo here. The argument passed to mtime represents the number of days since the last file was modified. Okay, so let's see, in the past 2 weeks, were there any configuration files modified on my system? Okay, so we'll change this to 14. Enter in my sudo password. Alright, and it looks like it takes quite a bit. I mean, we are searching through all the files and folders on the system. We're doing that with the / character. So I'll keep going and leave that running. You know what? I'm going to try to shorten it. Oh, okay. So, yep, that makes sense. I was gone for the whole week, and the week before I really didn't change anything. Maybe if we up this to 28, I might have changed some comp files as part of making videos. So let's look for that. And still nothing. Okay, which I'm actually pretty surprised by, because I'm pretty sure I did change some. So let's try in the last 100 days, because I'm pretty sure I changed some configuration files as part of these videos. Okay, well, I guess I was wrong. Alright, next section, locating files by size. Find can also locate files by size. For example, searching for files longer than 2 gigabytes in /var. So sudo find /var. The syntax there, okay, yeah, it's good. /var /size. So this must be greater than. So we've got 2 files here. Let's see on my system, and this is a great command for freeing up disk space. You can just look at anything that is really big, and if it's not needed on the system, just delete it, and you've got all kinds of disk space freed up. A good example of that are old images, like if you've upgraded to Debian 11, for example. Now, it might make sense to have Debian 10 on there for a little bit in case there's something wrong, but if you have Debian 9 on there, you just don't need it at all, and it's probably a pretty large file, so you can delete that and get that space back on the disk. The -size option displays files of sizes corresponding to the argument passed. some example arguments include dash size 100b, files which are exactly 100 bytes, and I'm surprised this is a lowercase b. I would think it's uppercase for bytes instead of bits, but okay. Dash size plus 100k, files taller than 100 kilobytes. Taller is an interesting word there. Dash size minus 20 capital M. So these are files smaller than 20 megabytes. And then dash size plus 2G. These are files larger than 2 gigabytes. Alright, note. To find empty files, we can use size dot dash size 0 lowercase b or find dot dash empty. Alright, so acting on the result set. Once a search is done, it is possible to perform an action on the resulting set by using dash exec. So find, there we go, dash exec. So every configuration file we find, we're going to change the permissions on it to 644. This filters every object in the current directory, which is specified with the star here, and below, which is an important word. It means all the child directories and folders relative to this parent directory here. For file names ending with .conf, and then executes the chmod chmod 644 command to modify file permissions on the results. So one thing that will definitely be on the test is what all of these numbers mean for chmod. So I'm going to get a refresh of that from the AI. Okay, so explain. So remind me of what 644 means and what all of the other options are. Okay, so we've got three numbers. We've got 6, 4, and 4. The 6 is in the first group, the 4 is in the second group, and the last 4 is in the third group. So the first group, the furthest to the left, that represents the file's owner. The next group represents the users who belong to the same group as the owner. And the third group represents users who are neither the owner nor part of the group. So the first digit represents the owner's permission, the second digit represents the group's permission, and the third digit represents the permissions for the others. And that makes sense because the owner, group, and others places are the furthest to the left, the middle, and then the furthest to the right. So the first digit, meaning the digit furthest to the left, represents the owner's permissions. The second digit, the one in the middle, represents the group's permission. And the third digit, the one furthest to the right, represents the permissions for others. That makes sense because the places from left to right are owner, group, and users. Okay, so the digits themselves go from 1 through it doesn't really say. So let me ask that. What is the range of digits that are valid for each group? The owner for each for each set of permissions. All right, so it's not a range 1 through 7. So the first digit in the octal number, which represents the permissions for the file owner, the valid digits are 0, 1, 2, 4, and 7. So 0 would be no read, write, or execute permissions. 1 would be execute only. 2 would be write only. 4, not 3, 4 would be read only. And 7 would be read, write, and execute only. And now this might be like, okay, this makes no sense. 1, 2, what happened to 3? 4, what happened to 5 and 6? Well, that's decimal, so it's not in decimal. These are all groups of 3 binary numbers like this. These are octal numbers. So so these are octets, and it looks like the only so it hopefully it makes more sense to think of it that way, because all you have it like this, which is a lot more intuitive, hopefully. So here, converting this from binary to decimal is 0. Converting this from binary to decimal is 1. Converting this from binary decimal, this is the 2's place, and the 2's place is turned on, no other place is turned off, so it's 2. And then here, this is the 4's place. So if we wanted to represent a 3, we would turn this on here, but that's not really following the same kind of pattern. So we've got a 4's place turned on here and nothing else turned on, so this is a 4. And here we've got everything turned on, so we've got the 4 place, the 2 place, so 4 plus 2 is 6, and then the 1's place plus 1, so that's 7. And it's the same for every single one. Okay, so that's a good refresher. Let's continue moving on. So this filters every object in the current directory, ., and below for file names ending with .conf, and then executes the chmod 644 command to modify file permissions on the results. For now, do not bother with the meaning of open, close, curly brace, backslash, semicolon, as it will be discussed later, and the open, close, curly brace is wrapped in single quotes. Alright, next section, using grep to filter for files based on content. And I need a quick break here. We're at the 20-minute mark. I'll be right back. Alright, welcome back. I'm ready to keep going. So now we're going to use grep to filter for files based on content. Grep is used to search for the occurrence of a keyword. Consider a situation where we are to find files based on content. Alright, so here we go. I'll run that on my home lab. Alright, we got all kinds of results there. This would search every object in the current directory hierarchy specified by a dot. That is a file -type f, and then executes the command grep LPI wrapped in double quotes for every file that satisfies the conditions. The files that match these conditions are printed on the screen -print. The curly braces are a placeholder for the find match results. The curly braces are enclosed in single quotes to avoid passing grep files with names containing special characters. The -exec command is terminated with a semicolon, which should be escaped \semicolon to avoid interpretation by the shell. Adding the -delete to the end of an expression would delete all files that match. This option should be used when you are certain that the results only match the files you wish to delete. So what you could do is run it without the -delete, and then once it actually does list all the files you're looking for, then just add the -delete afterwards. In the example below, find locates all files in the hierarchy starting at the current directory, then deletes all files that end with the characters .bak. Okay, so we're not going to do the delete, but if we were to do that, let's see the files that would be removed. Okay, so no files. If there weren't any results and I wanted to delete those results, then I could add the delete after I did this once. So that's what I'd recommend. Always do it without the delete, and make sure that you're not having any false matches before you do the -delete. Next section is archiving files. The tar command, archiving and compression. The tar command, short for tape archiver, is used to create tar archives by converting a group of files into an archive. The archives are created so as to easily move or back up a group of files. Think of tar as a tool that creates a glue onto which files can be attached, grouped, and easily moved. Tar also has the ability to extract tar archives, display a list of the files included in the archive, as well as add additional files to an existing archive. The tar command syntax is as follows. So tar, operation and options, file name, file names, or archive name, and then file names you want to archive. Alright, so operation. Only one operation argument is allowed and required. The most frequently used operations are --create, which is -c, create a new tar archive, --extract, which is -x, extract the entire archive or one or more files from an archive, --list, also known as -t, not -l, display a list of the files included in the archive. Alright, so options. The most frequently used options are --verbose, also -v. Use the files being processed by the tar command. Then --file equals archive-name or -f archive-name. Specifies the archive file name. So archive name, the name of the archive, file name, a space separated list of the file names to be extracted, if not provided the entire archive is extracted. Okay, so next section is creating an archive. Let's say we have a directory named stuff in the current directory and we want to save it to a file named archive.tar. We would run the following command. So tar-cvf archive.tar stuff. There we go. This is what those switches actually mean. Okay, so I'm not going to do this on my home lab because I don't have a folder named stuff and I don't want to create this unnecessary file archive.tar. But here's what these switches actually mean. So we use the switches -c, v, and f. So -c would be to create an archive, -v would be to display progress in the terminal while creating the archive, also known as verbose mode. -v is always optional in these commands, but it is helpful. -f allows to specify the file name of the archive. In general, to archive a single directory or a single file on Linux, we use tar-c for create, -v for verbose, list the progress in the shell as it's going, and then -f for, I don't remember, to specify the file name and not just have it be the same name as the path, I assume, or the same name as the file you're archiving, I assume. So and then feed it the file name and then give it the file you want to archive. Alright, so note, tar works recursively. It will perform the required action on every subsequent directory inside the directory specified. To archive multiple directories at once, we list all the directories, delimiting them by a space in the section. So there we go. So tar-create verbose and then file name. Yep. So there we go. We can add extra things, and then it all goes into one archive. This would produce an archive of stuff1 and stuff2 in archive.tar. All right, so next section is extracting an archive, and let's say we're only at the 30-minute mark. Making a lot of good progress at this, so it'd be nice if I could. Yeah, you know what? I'm gonna try to finish this out, but I need another break, so I'll be right back. All right, welcome back. I probably will need to talk into the microphone in order to get to good audio, but in addition to that, I probably will need to make this a part 1 and then go and finish this up in a part 2. I just kind of got a lot going on right now. I've got just got back from a trip, and I've got another trip in 2 days here. So I'm doing what I can, but there's a lot of other things on my mind. All right, so we're on extracting an archive. So we can extract an archive using tar. So tar, oh, did we already finish this? Oh, so this is creating an archive. This is extracting it after it's been created. So we can see we don't have that -c anymore. So extracting an archive, we can extract an archive using tar. So tar-xvf. So we still have the v and the f. The v is verbose, the f is the file name, which we've got here, but now we have an x instead of a c. This will extract the contents of archive.tar to the current directory. This command is the same as the archive creation command used above, except the -x switch that replaces the -c switch. To extract the contents of the archive to a specific directory, we use -C. So here we go, and this is to I don't know why it's a C. It should be like a D or something, -directory, but it's a C. So, and not only that, it's a capital C, but we're extracting this one to /temp. So this will extract the contents of archive.tar to the /temp directory. And there we go. We've got the contents of it here. Why don't we have this second? Oh, okay. And we don't have this second one because this is a file within this. So we'd have to change directory to this and do an ls in order to see it. We could also use a tree uppercase L to see like the nested levels within the tree. And then we could see this here. But with this command, all we'll see is the immediate child contents of the parent folder temp, which is this folder stuff. All right, so compressing with tar. The GNU tar command included with Linux distributions can create a .tar archive and then compress it with gzip or bzip2 compression in a single command. So tar-czvf, name of the archive.tar.gz stuff. So this is interesting because if you're a Linux user like I am, where you just get it done and you don't really care that much about why things are until now that you're trying to get this cert, you know, you see this all the time. It's like .tar.gz. Well, why can't we just .gz it? Why can't we .tar it? It seems like we're doing two things when instead we could just do one. So the answer is the GNU tar command included with Linux distributions can create a .tar archive and then compress it with gzip in a single command. So, and that's with the Z. So this command would create a compressed file using gzip algorithm-s. While gzip compression is most frequently used to create a .tar.gz or .tgz files, tar also supports bzip2 compression. This allows the creation of bzip compressed files, often named .tar.bz2, .tar.bz, or .tbz files. Okay, so before moving on, let's ask the AI a question here that I have. I love that I can do this. What a world we live in. This is absolutely amazing. So the question will be is, if I archive, if I create an archive using tar, why would I need to also compress it? Why would I also need to compress it? Why can't I be satisfied with only archiving or compressing? Why do I need both? All right, so this is something I've always been curious about. So the answer is, creating an archive using tar and compressing it are two distinct steps, each serving different purposes. Understanding the differences and benefits of both processes will help clarify why you might need both archiving and compressing. All right, archiving with tar. Archiving is the process of collecting multiple files and directories into a single file, often called an archive. The tar command is used for this purpose in Linux systems. Archiving is helpful for organizing and storing a group of related files, maintaining their directory structure, and preserving permissions and metadata. Okay, so like if you're moving it around, you don't have to concern yourself with, and we saw this in some of our prior commands. If you do an ls, if you do there are certain commands where you have to do like a -r, so like recursive. Well, if you archive the file, if you archive the directory, then it's just one entity, and when you move it around and stuff, you can move that whole entity without specifying any additional sort of option. So archiving is helpful for organizing and storing a group of related files, maintaining their directory structure, and preserving permissions and metadata. However, tar does not perform compression on its own. So while archiving bundles the files together, it does not reduce their size. This means the resulting tar archive can still be quite large, especially if it contains numerous or large files. All right, so there's the answer right there. I'm pretty happy with that. So the primary reasons for compressing are space savings, faster transfers, and resource efficiency. So the answer is, you want to archive a directory so that it's seen as one entity, and it's not just one entity, so like all the permissions are preserved. You don't need to use a special option to say that you're dealing with the whole thing. So that's why you would archive it, but that does not make it faster to transfer. To do that, you would use gzip, and it'd be pretty hard to use gzip if it was not one full entity, because what are you zipping? Yeah, tar basically groups it together as one thing, and then gzip compresses that whole thing. All right, so here's the command here: -c for create, z for it's the GNU zip, gzip that is built right into tar, and then v for both, show us the progress, and then f for file name. Alright, so this command would create a compressed file using the gzip algorithm -z, while gzip compression is most frequently used to create .tar.gz or .tgz files. Tar also supports bzip2 compression. This allows the creation of bzip2 compressed files, often named .tar.bz2 or .tar.bz or .tbz files. To do so, we replace -z for gzip with -j for bzip2. There we go. So we're using the -j, which is a different kind of compression. Gzip compression is the most frequently used, but there are other kinds of compression. For example, .bz, which we can use with -j. So next we'll talk about decompressing, but before moving on with that, I'm going to ask the AI what are some differences between gzip and bzip2, and why would you choose one or the other? So what are the differences between gzip and bzip2? Why would you choose one over the other? All right, so here's the answer. So in summary, the choice between gzip and bzip depends on your specific requirements, such as whether you prioritize compression speed, decompression speed, compression ratio, or resource usage. Each format has its strengths, so consider the trade-offs and select the one that best fits your needs. All right, so okay, so the purpose of either is to reduce file sizes. The differences between the two I actually lost because I accidentally clicked out of the dialog box. So I guess I don't know if I want to okay, so this is interesting. ChatGPT is actually expressing its opinion. I've really never seen it do that before, but this seems to be what I was looking for. So, in the opinion of ChatGPT Web, both gzip and bzip2 are useful compression tools, but they have different compression ratios and performance characteristics. Gzip tends to have faster compression and decompression speeds, while bzip offers higher compression ratios, but may be slower in comparison. Therefore, the choice between gzip and bzip compression depends on the specific use case and the balance between file size reduction and compression decompression speed required. So, one consideration between the two could be the time it takes to transfer the file over the internet versus the time it takes to compress or decompress the file on a personal computer. So let's say you have two computers, one computer, and they both, one computer A wants to send the file to computer B. Computer A is got all the CPU memory in the world. Computer B, likewise, very, very advanced computer. But the network between computer A and B is very slow. You have 100 megabit connections, and you're not going to send that file very quickly. So in that case, you would want to use bzip2 because it would compress that file down to a smaller size that would mean sending less traffic over the internet, so it would mean it would get there faster, and the compression time and the decompression time, since both computers are very powerful, would not cause a significant delay. So your bottleneck is the network, so you want to use a compression algorithm that optimizes for that bottleneck. So you want one that compresses the files to a smaller size versus one that takes a longer time to compress or decompress. So alternatively, let's say you have a Raspberry Pi or a Potato PCA, sending to another Raspberry Pi, Potato, whatever, old school computer PCB on a huge, 10 gigabit, 1 gigabit, just the most fastest, modern, sophisticated network you can imagine. And of course, let's just pretend for a bit that whatever Potato PCs are capable of a 1 gig at least network interface card. That might not be the case, but this is not a perfect example, but it's just kind of a thought experiment that I think is useful. So in that case, it's going to take a long time to compress or decompress the files because the computers doing so are not very powerful. But it won't take long at all to send the file across the network. So in that case, you want to choose a compression algorithm that optimizes for that compression and decompression speed, and that would be gzip, because you're not concerned with the size of the file so much because your network can transfer files so quickly. The bottleneck is on the PCs themselves and the speed at which they can compress and decompress. All right, so hopefully that makes sense. Moving on, to decompress the file, we will replace -C with -X, where X stands for extract. All right, so we got a -X for extract. We've got a -Z for using the gzip algorithm, and we know to use that with the .gz here. If it were .bz, we would use the -J here instead of the -Z. -V, make it verbose, show us the progress in the bash output, standard out, and in the -F means we can specify a file name. So gzip is faster, but it generally compresses a bit less, so you get a somewhat larger file. Bzip is slower, but it compresses a bit more, so you get a somewhat smaller file. In general, though, gzip and bzip are practically the same thing, and both, gzip and bzip are practically the same thing, and both will work similarly. Alternatively, we may apply gzip or bzip2 compression using gzip command for gzip compressions and the bzip command for bzip compressions. For example, to apply gzip compression, use gzip file to compress. So you can use this instead of the -Z or the -J. Sometimes it's a bit nicer to do it in two separate commands so it's more clear what you're doing. Okay, so gzip creates the compressed file with the same name, but with a .gz ending, and then gzip removes the original files after creating the compressed file. So the bzip command works in a similar fashion. To uncompress the files, we use either gunzip or bunzip2, depending on the algorithm used to compress a file. Okay, so before moving on, I'm going to do a bit of hands-on here. I just want to remember how to do this because this is awesome. So we saw that we can get books, right? So let's try to find where I found those free books. So I think Open Library might be it. Okay, so let's get Game of Thrones. Now, I don't know why you have to check it out. Is this it? I forget. There was a there was a thing that we did. All right, so here's Fantastic Mr. Fox. Is this it? I forget what it was. Well, shoot. Okay. I forget what it was. So we're in 103.32, which is here. So I'm pretty sure it was here. Oh, yeah, here it is. So, okay, yeah, this is what I'm looking for. So this Project Gutenberg. Yeah. So let's get a book from Project Gutenberg. What's a book I really like? I don't even know. I mostly like read the internet. I don't really read. Like I read a lot, but I don't read books. I read the internet. So let's just get a random book. Okay, so I want one in English. The Admiral's Daughter. I guess that might be good. General Science. That might be good. I like science. Omens and superstitions of southern India. That might be interesting. I certainly don't know much about that. Oh, you know what? Let's just get Romeo and Juliet. Right? Yeah, I like that. It's good. Definitely familiar with that. Okay, yeah, let's do that. Romeo and Juliet. So here's we want the plain text. There we go. So perfect. Yeah, this is great. Okay, so now I can do make a DR. We'll make it Romeo Juliet. We'll do that, and we'll do wget here. Okay, and now we've got it. So here's the PG. That's all of Romeo and Juliet. So I'm gonna try to read a little bit from it. I'll do a random. So what I think we're able to found. Yeah, so like this exercise, I think is where we did that. So we can do SCD-N. Oh, this is to find. Shoot. Okay. Let's ask the AI. I feel like a lot of this stuff is out of date because you can just ask the AI. Write me a bash script to print out 10 lines randomly from a text file. Okay. So I guess I'll try this. All right. So now I'll do vi random lines .sh set paste I. There we go. WQ, and now I need to do mod plus X. Oh, I didn't even know it was named this. I just came up with this on my own. But cool. Okay. All right. So now let's run the script. It was like, yeah. There we go. So the tiers have got small victory by that. Enter Benolio and Mercuto. What's here? A cup closed in my true love's hand, sitting in the sun, under the dove house wall. Poor living corpse, closed in a dead man's tomb. I hear thou must, and nothing may prorogue it. Paris, sir, go you in, and madam, go with him. Till then, adieu, and keep this holy kiss. That sounds bad. Alright, so yeah, I just wanted to do that to kind of jog my memory on how this works, and I ended up not doing that and just going right to the AI, but in the modern day, I think that makes sense to do. Alright, so I don't need this lesson 1 anymore. Okay, so here's where I am. So I just want to show the compression. So if I do a ls-l, I'll do a -lh. There we go. So now we can see that this is 166K. So let's do let's turn it into an archive. So we're going to do tar create. We'll create an archive. We'll show the progress in the bash standard out, and then we'll use this F for a file name, and then we're going to so here's the thing, you can't this is for directories. So if I do tar -cvf on the Romeo, yeah, so I can do it on oh wait, what? I'm confused. Oh. Okay. Never mind. You can do it on things that aren't directories. So I made an archive named test. We can see if we do the -h, the test is actually a little bit bigger, probably because it has some of the like metadata that it's an archive. So let's use gzip on test ls-l. Okay, so now it's test.gz. If I do a -h, there we go, much smaller, 64 kilobytes as opposed to 166. So I'll do a gunzip on test ls-lh, and there we go, it's back to the 170. There we go, and I'm removing test, and there we go. That's what I wanted to do. Okay, so moving on to the next section is the CIPO command. And you know what? I'm kind of oh, and I'm almost at the hour mark, which is a good it's a good time. So I'm going to cut it into 2 parts. The next part will be about this. So thanks for watching, and stay tuned for the next part.